2, we're doing the building blocks for something that you'll do in your next course, Algebra 3 or Honors Pre-Calculus. And if you know anyone currently in Honors Algebra or in Honors Pre-Calculus or Algebra 3, they're also doing Trig right now. Okay? And they may have shown you, or you may have heard them talk about something called the unit circle. And we're not doing the full unit circle, but essentially, listen up. Essentially what we're doing today is the building blocks of the unit circle. So whatever you put into learning right now will pay off next year when you're in Trig. Those students in Honors Pre-Calculus and Algebra 3 have to memorize the unit circle. So if you do the work this year, it may pay off and make memorizing the unit circle easier. Okay? So I suggest you do the work. Now, you don't have to write this down. I want you to have a conversation with your group. Okay. Oh, and I forgot to fix this, but I labeled my quadrants wrong. We'll get to this slide here in a little bit, but this we did, I think it was Monday, the general definition for the trig functions, where we changed from like SOHCAHTOA, and we changed it to a more algebraic approach where we said sine was y over r, cosine was x over r, and tangent was y over x. So we'll get there in a minute. But what I want you to do is have a conversation with your groups right now. What do you know about the signs that would be positive and negative of x and y in each of the 4 quadrants? And I had labeled my quadrants incorrectly. So go ahead and have that conversation. What do you know about the signs of x and y in the 4 quadrants?
Positive quadrant. Positive, negative.
Quadrant 3 would be negative. Quadrant 3 would be negative. And quadrant 4 would be positive.
Okay, as I'm eavesdropping around the room, these are the discussions I'm hearing. So hopefully you're talking about x is positive, y is positive in quadrant 1. Everything is positive. In quadrant 2, x turns negative because you're going left, but y is still positive because you're going up. In quadrant 3, they're both negative, and in quadrant 4, x is positive, but y is negative. Okay? So now I'm going to ask you this question. Using that knowledge and the knowledge that of the notes we took earlier this week in section 9.3, and remember in section 9.3 when we were working with R is always positive. We never mark R as a negative. What do you then know about the positive and negative signs of the trig ratios in each of the 4 quadrants? So we have 6 trig ratios, but you and your group can really focus on the 3 basic trig ratios, sine, cosine, tangent. So the conversations you should be having right now should be, what's the sign of each of the trig ratios in quadrant 1? Sine, cosine, tangent. In quadrant 2, what's the sine of sine, the sine of cosine, and the sine of tangent? Okay? And so do that for all 4 quadrants. Yeah. Go ahead and have that conversation.
Alright, so
So in the
first
first
one
quadrant,
positive everything. Positive everything.
positive second quadrant.
Quadrant 2. This is where certain
Wouldn't
ones will be
y go
positive.
negative?
So the y ones would be y over r would be positive, so sine would be more positive. And then the 2 would be negative. Quadrant 3, all will be negative. Because you'll have tangent.
Oh, since they have x and x is positive.
Quadrant 4, it's going to be the opposite of quadrant 2.
Wait, x is not positive.
Cosine. Cosine will be positive with sine.
Oh. And then yeah.
Okay.
Well,
So, what did you discuss in quadrant 1?
It's all positive.
It's all positive. Okay, you don't have to write this down because we're going to write it down on the next slide. But it's all positive in quadrant 1. So to be real honest, I just love quadrant 1. It's just always positive. I never have to worry about sign errors. It's easy. Okay, what happens in quadrant 2, Rihanna?
It goes negative, or it goes positive, negative, positive. Like sign is positive. Cosine
Sine is positive. Cosine is
negative.
negative.
Tangent is positive.
Why is tangent positive?
Oh wait, it's negative.
It's negative, isn't it? Right? So like sine is the only one. Remember, in quadrant 2, x is negative and y is positive, but r is always positive. So sine is the only one where you're doing positive over positive, and you're going to keep a positive. But in both cosine and tangent, you have one positive and one negative value, because x is negative, but r is positive. Y is negative, but x is positive. And those are going to produce negative ratios. Now, we would say if sine of theta is positive, what other trig ratio will also be positive? Cosecant. It's reciprocal, because when you flip it, you don't change its sign, you just flip it. So really in quadrant 2, only sine and cosecant will be the positives. And I'm going to just list the positives so that I don't have to list everything.
Yeah, you don't have the negative side of things anymore.
Okay, what happens in quadrant 3 then?
They're all negative.
Except for tangent.
Except for tangent.
Oh,
And cotangent.
okay. So in quadrant 3, x is negative and y is negative. When we're doing sine and cosine, that's one negative and one positive because r is always positive. So a negative divided by positive and a negative divided by positive is going to be negative. But when you get to tangent, if x and y are both negative and you're doing y over x, a negative over a negative is a positive. Okay, so be careful there. I heard a lot of groups saying that everything was negative. Only x and y are negative, which means the tangent is going to be positive. What else besides tangent will be positive in quadrant 3 then? Cotangent. Okay. And then what do you suppose is going to be true in quadrant 4? Only cosine will be positive. Okay. So you have a positive x but a negative y. Okay. That means sine is going to have a negative y but a positive r, so it's negative. Tangent is going to have a negative y but a positive x, so it's negative. Only cosine will have a positive x and a positive r for a positive value. So cosine is the only positive one in quadrant 4. Okay. So in each of the other 3 quadrants, where not everything is positive, there is one trig ratio, and it's reciprocal that will be positive. Okay. So now you need to write that down in your notes. And this is the slide. I would copy something like this down in my notebook. I would draw like my 4 quadrants and just label like what's positive. If you need to go back later and go ahead and list out whatever is negative, you certainly can, but if you know what's positive, then you can assume the others are negative. So on this slide, I did go ahead and list the positive trig functions, and I included their reciprocals. So like sine and cosecant are positive in quadrant 2. Tangent and cotangent are positive in quadrant 3. And cosine and secant are positive in quadrant 4. Now, if you went back to your homework assignment from Monday, which was the trig ratios of any angle around the coordinate plane, where we would like get a point on the terminal side of theta, like 8, -6. And you had to plot the point and label the sides and find the missing side. if you went back and looked at that homework assignment, these things would be true depending on where your terminal side was. And we kind of mentioned that in our notes on Monday. I know it's been a while, but if you ever drew your triangle in quadrant 4, when you labeled your triangle, you would have labeled the x positive, the y negative, the r positive, and it would have come out that cosecant and secant were the 2 positive ratios. Okay, so this is working always on the angles around the coordinate plane, not just for the ones that we're going to look at today. So this is always true in all the 4 quadrants. Now, we have a fun way to remember that. Okay, like, please excuse my dear Aunt Sally, that type of thing. We say all students take, got my teeth? Calculus. All students take calculus. And so you'll hear me say that a lot. All students take calculus. It starts in quadrant 1 and then it moves counterclockwise in the order of the quadrants. Okay? I mean, obviously for quadrant 1, all means all of them are positive. So why do I say students in quadrant 2?
Sine.
Because it starts with an S. So take is tangent and calculus is cosine. Now, if you want to make up your own little rule for all students take calculus, you certainly can. I've heard another version, but you cannot leave from AOA. Where? It says all science teachers are crazy.
Like, where'd the R come from? Like, if you're
No, there's an extra letter word in there. That's the other part. I'll never say it.
You're on recording, Charlie. What are you gonna do?
Only the people in AOA watch YouTube.
You don't
I'm
know.
gonna share that video.
Don't share the video. Don't share it. Okay. Well, that one, you're right, TJ. That one doesn't even work because there's an extra word. So you probably want to stick with all students take calculus. Okay. You'll also see me sometimes draw it out in my notes, or like if I'm doing an example for you, and I just write ASTC. Okay, so same thing. But make sure you know what order the letters go.
Or XD.
I just want to make you guys feel like we had a special secret together. You could tell any of the science teachers what I said. Stand by it. I'm joking. Okay, jot these things down for me, please. Those people, like in Algebra 3 and Honors Pre-Calculus, who are working with the unit circle, they're a level above us because they've done all this like back work. So what happens when you memorize the unit circle, you don't have to do these 4 steps. So it's less work, even though it's more work to know the unit circle, but it pays off in the end. You know how like that question Kaden asked about on the homework? Like when I was doing those yesterday, I would graph 8 pi over 3 by doing like a full revolution and then 2 pi over 3 more. And then before I found my reference angle, I would go in and do coterminals. Because our main goal here is to just like find that reference angle right away, I'm going to say, go ahead and make sure theta is between 0 and 360 and 0 and 2 pi. So that kind of goes to Kenzie's question, did I draw the negative angle or was I drawing it like the positive angle? I mean, you really want the one that's between 0 and 360 or 0 and 2 pi so you can do the reference angle. So just get it right away. Okay, so find the coterminal angles. Step 2, find theta prime, which you should recognize theta prime is reference angle. Okay. Now, today, and on quizzes and on tests, if I'm asking you to find a trig function of an angle without a calculator, that angle either needs to be quadrantal, so that you can use those points 1, 0, 0, 1, 0, -1, -1, 0, or that angle must have a reference angle equal to one of these angles. So when you find the reference angles on your homework, they should come out to be 30, 45, 60, or in radians, power 6, power 4, power 3. And the reason why that is we're going to use the special right triangles, which we know how to draw, 30, 60, 90, and 45, 45, 90 triangles. So step 3 is you'll be able to evaluate the trig function, and you're going to use the special right triangle to do that. So you're going to see me labeling sides of special right triangles. Now, earlier in the chapter, I had given you a pink half sheet for homework. And on that pink half sheet, you had to label the sides of a 45, 45, 90, label the sides of a 30, 60, 90, and then I had you do all 6 trig ratios. If you want to get that out and look at that as we're doing our homework or our practice examples today, there's a connection there. Those sine, cosine, tangent, and reciprocal trig values on that pink paper are really the only kinds of ratios you're going to see today. It's just they may be positive or negative depending on which quadrant they're in. So you only have a limited number of answers when we keep working with the same reference angles. Not right now. Okay. And then we're going to use the quadrant where the terminal side of theta is to check our signs. Now, really, number 4 should already be done. You should already have the right sign, and you'll see this when I draw the picture. But this is where I'm using, all students take calculus. So I'll just draw a little picture here to kind of make sense of what I mean. And in math, one of the easiest mistakes to make on quizzes and tests is to forget a sign. So all students take calculus. It's just a really quick way after you did all your work to make sure that if it was supposed to be negative, you have the negative. If you have it marked negative but it's supposed to be positive, you can change it back to a positive. That way you won't be docked for the wrong sign because you'll just have checked it with all students take calculus. So we're going to put all these things together and do some examples. Okay, and then, like I said, you'll have some time hopefully to work on your homework assignment. So here's my first example. The sine of 135 degrees. If I ask you the sine of 135 on a no calculator test, well, you can't type that into the calculator then. How are you going to do it? Use your special triangles because it should have a special angle as a reference angle. So, check number 1. Is this between 0 and 360?
Yes.
Yeah. So then step 2, you can go ahead and graph it and find its reference angle. Where is 135?
Quadrant number 2.
Quadrant 2. Now I'm going to be less careful about my angles. I don't really care about my spirals or my directions at this point because what I really want to know is what's that reference angle right there? In quadrant 2, remember those two angles are supposed to make 180. And since I already have this one between 0 and 360, I just have to subtract 135, and I think, Josh, you said 45 degrees. This is a 45-degree angle. And then what I really want to do is think about that. Now I'm going to draw it like a triangle. And this is where anybody who found your pink sheet with your special right triangles, you can look at that 45, 45, 90 triangle, and you know the side lengths. They always come in the same ratio. What's the ratio for the 3 sides of a 45, 45, 90?
1, 1, radical 2.
1, 1, square root 2. Okay. Which one is square root 2? The hypotenuse. In this case, that's going to be the radius, right? And when we mark the radius, it will always be positive. Okay, so this is going to be square root 2. When I mark these two sides with my 1s, I mean, technically in the picture, since I'm going left, this leg should be -1, and this leg should be +1. And then I'm trying to calculate the sine of 135. So I would use which values?
Opposite over hypotenuse.
You could think about it like opposite over hypotenuse. So 1 over square root 2. You can think about the general definition, y over r. Y is up and down, so we still get 1 over 2, or 1 over square root 2. And what do you have to do with that?
Multiply with square root 2.
Rationalize your denominator, so that's square root 2 over 2, and that would be my answer. Now, step 4, I guess I don't need to draw it when it's already drawn right here. Step 4 was check your sign. Well, that's all students. In quadrant 2, sign is supposed to be positive. Is your ratio positive?
Yes.
Yes, you got it right. Let's do one in radian.
Whoa. Curveball.
The secant of 7 pi over 6. Okay, so remember, we want our angle to be between 0 and 360 or 0 and 2 pi right away, because then we can just like do our reference angle work. So let's just get to the business of 0 to 2 pi. Is 7/6 pi in between 0 and 2 pi?
Yes.
Is 7/6 in between 0 and 2?
Yes, it is.
Yes. What is 7/6 as a mixed number?
1
and
and
1
1.
and
1 and 1/6. Okay, excellent. Okay, so we're ready to graph it. Where will 7/6 pi be? Third quadrant. And so we want that reference angle. So I'm gonna mark it with the theta. We want that reference angle right there, going back to the x-axis. So remember in quadrant 3, that's your overflow angle. So you would take 7 pi over 6, which we just said was 1 and 1/6. And we will subtract 1 pi, which will leave us with
1/6.
pi sixths, which is which angle?
Oh,
30
it's like a
degrees.
It's the 30 degree. Okay. So I always remember like pi over 6 is not 60. And pi over 3 is not 30. They mismatch. So this is our pi over 6. I'm going to go ahead and mark it as pi over 6. If you call it 30, that's fine. It's the same thing. Okay. Now, when you're labeling this triangle, if pi over 6 is the smallest angle, like 30 degrees is in a 30, 60, 90, then the side opposite has what value? The smallest side, which is 1. And because this is in quadrant 4, this must be, or sorry, quadrant 3, must be down 1, right? Look at the picture. It's going down 1. What's the other leg of the 30, 60, 90, the longer leg?
Are you talking about rate
Its value.
formula?
Square root 3. And this is negative square root 3. And what's our hypotenuse in 30, 60, 90? 2. And this is radius, so it's always positive. So if you're calculating secant, what's your ratio for secant? R over x. So then I'm going to do 2 over negative square root 3. Rationalize it. That's negative 2 square root 3 over 3. If you're looking at that pink sheet, you filled that out for me. That is the secant of 30 degrees. 2 square root 3 over 3. It's just that it's negative because it's in quadrant 3. Okay, so this would be in all students take calculus. All students take only tangent would be positive, so and cotangent, so the secant will be negative. Yeah, Rihanna.
Okay, so when we did our bow ties,
Yes.
so like does that mean like, so I know like it's easy to think about it with like quadrant 3 and quadrant 1 that like it all relates back to that, but every single one that I outlined
Yes.
in one bow tie, does that all relate to the smallest one in quadrant 1?
Yes. So that's exactly. See,
Oh.
remember your bow ties. You just led me right there. Thank you, Rihanna. Okay, the more familiar you are with the angles that we talked about yesterday and that you highlighted yesterday, the easier this is going to be. And remember your bow ties. So I think what Rihanna is asking, just to like get at her point there, we just did 7 pi over 6, which was this one right here, and we had drawn this whole bow tie. I'm sure I can see where I'm going. We had drawn this whole bow tie. So this was a 30-degree or a pi over 6 angle. This was a 30-degree, this was a 30-degree, and this was a 30-degree. So yeah, you can also sort of like, for the radians, hint, hint, wink, wink here. If it's 7 pi over 6, what's its reference angle going to belong to? Pi over 6. If your angle was 25 pi over 3, it belongs to pi over 3 family. Now, that doesn't work for every fraction. Like, it doesn't work for things that are over 5 in terms of reference angles, but it works for 6, 3s, and 4s, which are the special angles you need to know.
Are we normally going to have those ones?
They have to be, if I'm down on the calculator part, no calculator part, they have to be those angles.
Okay. Do we get to use that on the quiz?
No.
Okay.
Also,
GG's.
I have a question. So does that mean like if you had a revolution that went all the way around that landed on one of those like special
It's pi over 3.
so it'd be still
Or pi over 6, yeah. Yeah. So, like, this was pi over 6. If we went all the way around, that's 12 pi over 6. And if we went, like, to, like, 17 pi over 6, we'd actually be over here at 150. But that'd be a pi over 6 angle. Yeah, every time. Okay, so now I'm going to give you 2 tougher ones. And I'm going to let you do more of the work before I put mine up.
Oh, negative.
Well.
Wait, hold up.
No,
Can I say something real quick?
At 360.
Aren't you gonna have to do a coterminal angle?
Yes, that's why I called it tougher.
Come on, TJ.
But I like what you're saying, so I hope your classmates were listening and are going to do the same thing. Think about step 1. What are you going to do to start?
What if
I know.
You'll have to pay attention to the directions that it says to do it in that particular form.
Wait, so it's gonna be 60.
Oh, well, this is kind of nice, right?
It's quadrant 1.
It's quadrant 1, where everything is what?
Positive.
Positive. So this is not too bad. I just got to draw my angle. This is 60 degrees. I could go ahead and draw my triangle. Label my sides. That's 1 square root 3 and 2. And tangent would be opposite over adjacent, or y over x, either way you see it. So you would say square root 3 over 1, which is just square root 3, done. Cool. Okay? One more, and then you're done.
Hold up.
Okay, if you want to see those three. Okay.
Yeah, instead of X.
Cotangent of 16 pi over 3. That is more than 2 pi. Excellent. Thank you, Caden. Now, you already, based on my hint, hint, wink, wink earlier, you know what is the reference angle. Pi over 3, which is 60 degrees. However, you still have to figure out which quadrant.
Yeah, based on
So you got to do the coterminal work.
how many did you guys look back?
2 pi though. Wait, every 2 pi is from 9.
So 6 pi equals anytime it's
2, wait, no, 6
every
thirds.
2 revolutions.
Every 6 thirds pi.
Yes, we 2 revolutions.
Every 12. And then 4 pi over 3. Yeah.
A nice way to work, I hope that this is like maybe starting to feel a little bit better for some of us. A nice way to work is just to figure out in radians, what is 2 pi equal to so that it has a matching denominator, right? It's over 3. Well, just double your denominator. What would the numerator be? 6. So 2 pi is really equal to 6 pi over 3 because then that reduces to 2. If you subtract 6 pi over 3, you get 10 pi over 3. That's too big still, right? So then you have to subtract again. So I'm just going to say, I'm really subtracting 2 revolutions, 12 pi over 3. And what do we get? 4 pi over 3. But that's in between 0 and 2 pi. So this is asking us to do the cotangent of 4 pi over 3. In which quadrant does that exist? The third quadrant. Excellent. It's more than 1. It's 1 and 1/3. Kind of like what we were talking about on that special angles that we highlighted yesterday. So we know it's down here. And we already talked about, I can do the work for theta prime. It's the angle minus pi, the overflow. But I know it's going to come out to be pi over 3 right there. And remember, that's not 30 degrees, that's 60. So then this side is negative square root 3. This side is negative 1. That's 2. And if you're doing cotangent, what values will I use? Well, which one goes on top? I'm hearing different things. Negative 1, the adjacent side, or the x, over opposite, negative square root 3, or the y, right? It's x over y, or adjacent over opposite. Now, a negative over a negative is going to be a positive, and rationalize, you should get square root 3 over 3. Oops.
And that is also the
All students
cotangent of 60
take
degrees on here.
Okay. Tangent should be positive in quadrant 3, and it is. Okay, Brianna's going to pass out your homework assignment while I pass back your quizzes.
See, when I search up, that's not true.
Yes.
It comes up. When I search up bar,